a CLA and a CTA, but today I'm going to be talking about something a little bit different. I'm not specifically going to be talking about software. I'm going to be talking about understanding your test performance. I'm going to be joined by my co-presenter, Matthias Bordeaux from Studio Boards, my excellent co-presenter. So, a little bit of information about Delacorp, who we are. We're an NI Alliance partner. We have offices here in Austin and also one in Europe. Well, actually, not Europe. There had to be a LabVIEW joke in there, right? So, our leadership team is myself, obviously running the UK office. We've got Fabiola Della Cueva over in the corner, here in Austin, and also Luis Orozco. Is that a better pronunciation? Yeah. He's our hardware and measurements man here in Austin also. So, what do we do at Delacorp? We're a little bit different to most Alliance partners. We're kind of unique in that we generally work with teams who already have LabVIEW developers, test-stand developers within their organization, but they're looking to improve. They know that they could be doing things a little bit differently and a little bit better. So we help developers improve through software engineering process optimization. So that involves things like source code control, helping them implement source code control in a way that works for their organization. VI Analyzer tests, custom VI Analyzer tests to help them improve the overall quality of the code, especially if it's code that's being shipped external to the organization. We also help with best practices, so style guides, providing customized style guides so that they can measure their own code against some standard. And implementation of those things. We also help with automation tools. So if they've got a framework that they use but they want to improve the efficiency of that, we can help by writing custom scripting VIs to automate the process and improve their efficiency. Software architectural design as well. We can do code reviews. We can advise on your specific use case, the optimum architectural design to use. Automated test strategy. Within Delacorp, we have several engineers who have a strong, rich history in test automation in the manufacturing area. So we can help and advise with your strategy. And finally, hardware design consulting. We've got an excellent analog design engineer within our team. He's worked at NI previously, designed several of the boards that I'm sure many of you are using. So if you're looking for custom design or advice on your bill of material for your hardware design, we can help and advise with that also. We also develop toolkits. We won an award. So we won the LabVIEW Tools Network Product of the Year for our DQMH toolkit. It's a free toolkit. It's an example of the quality and the standard of the code that we deliver. So we put it out there to kind of show this is the thing that we can do. We can help with your application architecture. We can also demonstrate the scripting, the automation tools.
Hello everyone, so I'm Matthias Bordeaux, I'm owner at Studio Boards. It's a Canadian-based company with operations in the US and Europe as well. So I've been programming LabVIEW every day of my life the last 10 years. I'm one of the 3 fastest LabVIEW programmers with Darrell Nuttinger and the new champion Robert Mortensen since yesterday. My main area of interest is code deployment, keeping the control on your code, tracking your code, knowing how it's used, being able to update it. So all those things, and I'm really passionate about it. So with Studio Boards, we do mainly consulting, LabVIEW development, of course, with specialization in oriented object programming, database integration, hardware automation, hardware in the loop. We design custom APIs for our customers. We also consult in advanced architecture design. We help with software deployment, of course, and continuous integration, continuous code delivery, project management, data management, and we do offer custom training and as well also CPI for now.
So, is this presentation for you? If you are a developer who wants to deploy your solutions to test stations around the world, you should stay. If you're a test manager who wants to improve the efficiency of your test operation, you should definitely stay. You're in the right place. If you're a test engineer who's looking for a raise, you should definitely stay. If you're a test manager who wants to see, is there something that I can do to improve my operation, you're in the right place. A quality manager who wants to understand product yield, absolutely. A senior manager who wants to reduce the total cost of test of your test operation. Anyone who wants to monitor the performance of a test station. And if you just want to sit down somewhere because you had a hard night partying last night, you're welcome to stay. So what are you going to get out of this? Well, you're going to learn who we are and what we do. There's some free stuff. All of the videos that you will see, the demonstrations you'll see throughout this presentation are available. There's the bit.ly. I'll leave it on the screen for a few minutes and we can put it up there at the end so that you can grab those. So all of the demonstrations and videos are going to be available. They're available now.
Yeah, the videos are without audio.
Yeah, so the videos, they're up there now. There's no audio. When we finish this presentation, we'll get that audio overlaid with the videos and get them refreshed. We're going to share our experiences in improving manufacturing test. And you're going to get to see the solution that we've come up with. So, just to give a little bit of background, to give you the backstory, where we're actually coming from and highlight some of our experience. So, personally, I've spent 2 years working with contract electronics manufacturing companies. So, here we're talking about very high volume, tens of thousands of units per week, but very, very low mix, often 1 or 2 products, and zero rework policy. This thing doesn't work, we're going to test it, we're going to take a few seconds to test. If it doesn't work, we're just going to reclaim the materials that can be recycled and we're going to throw the rest away. It simply isn't efficient to start doing rework at that kind of level of volume. So that's one of our kind of areas of experience. My second area of experience then moved into, I spent 8 years working with an RF OEM manufacturer. So again, high volume, maybe not tens of thousands of units a week, maybe just single-digit thousands of units a week, but different in that we had a product line approach. So we had a portfolio of products that we could offer to customers, but an extremely expensive bill of material cost. These pieces of equipment were expensive to build. So if it doesn't work, you want to make it work. You want to diagnose the problem, you want to fix the problem, and you want to make it work so you can ship it. And these things were high-frequency products, typically around 40 gigahertz. So the cost of testing this thing is pretty high as well. These are expensive box-type instruments that we were using at the time, and it's an expensive test solution. So again, you want to maximize the impact of that test. And this thing, there's a little picture here. This is like the size of a postage stamp or something. So it's a tiny little thing, but it's expensive. So we're going from something that's quite small. My next section of experience was working for 5 years in satellite manufacturing. So we've gone from something that's the size of a postage stamp to something that's the size of a Volkswagen. So here you've got extremely low volume, so 1, maybe 2 units per year, and very high mix. Every single unit, every single payload is completely different. And regarding the cost of test, if you need to ask, you can't afford it. So, complete opposites, right? Surely very, very different. Well, let's do a comparison. So, I'm going to be looking in this comparison, and don't worry, there's a lot of information there. We're going to actually filter this out. What are the key drivers to success? So that's what we're going to be looking at. How long is the test campaign, and what is the cost of failure? So let's have a look at what's in common first. So, the key drivers to success. For the high volume manufacturer, we care about yield. If we're not getting high yields, we're not going to get the volume of product out to the customer. We don't want to have this big pile of scrap in the corner, so yield is key. We need high yield to be able to ship that to our customer. We also need a very, very low field return rate. We can't, if we're shipping 10,000 units per week, we don't want half of them coming back. We need that low, very, very low single-digit field return rate, maybe 0.5%, 0.3% might be typical. For the RF OEM, again, we need high yield. We can't have units not passing test. It's expensive to perform the test for this because we've got this expensive test solution, so we need that high yield. In the space industry, the key driver is quality. It's a very sentiment-driven industry. Your reputation is key, so quality has to be high. And in terms of field returns, well, that's off the table. There are no field returns in space. Other key drivers, obviously for the RF and for the space industry, there's a high cost to test. How long is the test campaign? Well, you can't really see that there, but for the contract manufacturer, 2 minutes or less to test a mobile phone handset, for example. For the RF OEM, our test duration was around 5 minutes. Was around 5 days. For the space industry, from testing the very smallest component to the final payload was around 2 years. So that's a huge test campaign. You don't want to be repeating any section of that. And in terms of the cost of failure, very similar for the RF OEM and the space industry, loss of customers. So in the RF OEM, the loss of a particular customer. In the space industry, if you have a payload failure or a failure in orbit, you may lose all of your customers because that sentiment will proliferate to all of the customers. They will lose confidence in you. So what is different? So for the OEM, takt time, ensuring that you're producing the right volume of product at the right time. The customer needs 10,000 units a week. You want to make sure that the flow of product coming through supports that 10,000 units a week. If they only want 5, you don't want to still be producing that 10,000 units a week because then you've got thousands of units going into storage, going into stores to wait to be sent to the customer. Resource level, again, you don't want thousands or tens of employees stood around if you're not shipping that product out to the customer. So resource level. Diagnostics for the RF OEM is another difference. There you're doing diagnostics. You want to know, why did my unit fail and how can I make it work again? For the contract manufacturer, you probably don't care. It didn't work, let's recycle and start again on the next unit. For the space industry, the results traceability is key. We need to know where how every single subassembly was tested, what was its performance, and that performance will be tracked and followed right through to the final payload assembly. And process traceability as well. Every operation that is performed upon the spacecraft needs to be tracked. So why would we measure those things? Well, in the contract electronics manufacturer, we're going extremely fast. A single drift in performance, for example, the test site, performance, maybe an instrument starting to fail or go out of calibration, or a change in materials in-feed into our manufacturing operation, it's going to have a huge effect because we're shipping thousands of units. Failure to monitor could lead to tens of thousands of units making it out into the field and then having to be subsequently recalled. So you need to monitor real time. And with that in-feed of product and that high volume, it makes it extremely difficult to change direction quickly. In order to produce those tens of thousands of units, you've got parts coming in from various suppliers, and it's difficult to switch those on and off quickly, so you need to monitor. For the RF OEM, efficiency. Efficiency is the key to monitoring. Why? It's an opportunistic market. Spot orders are the norm. You don't have this huge forward load of business. It tends to be spot orders. Can you give me 10,000 units in the next 3 months? So you need to understand your performance to be able to respond to that. It's highly competitive. There's loads of people out there doing this, and they're all doing it quicker and cheaper. So you need to remain competitive. You need to understand your capacity. Can you ramp up quickly? If we receive an order for 15,000 units next month, can you achieve that? What would it take to achieve it? Would it take more staff? Would it take more test systems? Can you achieve that? We need to understand the cycle times. How long does it take to test this thing? And if I receive a spot order for more units, how will we achieve that? Do we need to reduce that cycle time? How does that work? And planned maintenance. If we're just testing all of these products on this highly expensive test system, we need to understand, does its performance degrade over time? Is that affecting our ability to ship units to the customer? For space manufacturing, the cost of test is huge. So we must be confident that every single test result we have is valid before we move to the next stage. So we need to monitor, we need to understand that test performance. We can't afford to take a subassembly that's been packaged and fit it to a spacecraft and perform that process, that manual operation, and then have to remove that component and retest at a later date. It's an expensive operation. So we need to measure, we need to understand real time what is happening. And in the space industry, we simply don't have those obvious pass-fail criteria that we might have in other industries. Often we care about in-family performance. We don't care about an absolute limit, we care about how a device performed with respect to other devices in test. And then traceability is vital. We need to understand every test and manual process operation that was performed. So, in order to be able to measure, we need to be in control, right? So, why test? Why test in the first place? Well, did we design it right? If you're testing to understand that, then you've got problems. You need to call us, you need to hire us, talk to Louise, talk to Fabiola. If you're testing to understand your design, it's too late. Did we build it right? That's why we're testing. Did we put this thing together correctly? Are all the parts in the right places? Did we solder things down correctly? We want to know, did we build it right? We also want to know, did anything change? Did some of our amplifiers come from a different lot and they have different gain characteristics? So we want to know, did anything that goes into our final product change? So we also need to know what we're testing and how and what we're using to test it. So we care about things like the product serial ID. We want to know what it is that we're actually testing. We want to know about the test station that we're using to perform that test and the assets within that test station, individual box or PCI card based instrumentation that we're using to perform a measurement. We need to be able to track that. We need to be able to test track the software that we're using to perform that test. Version numbers, both test and users, sequence file versions. That's it, right? Surely that's all we need to know. Well, no. We need to know things like driver versions. What driver are we using to drive this box instrument? Because maybe it behaves differently. We need to know about National Instruments toolkits that we have installed on our test station. Are they consistent versions? Is there a difference in performance from one version to another? Max, for example.
So I'd like to introduce BLT for LabVIEW, which is a tool that has been successful the last 4 years on the Tools Network. And the reason is why that's what we used as a framework and the API available with BLT to come up with the solution we're going to show right after. So BLT stands for Build, License and Track. Build because it allows you to automate the deployment and the building process of your LabVIEW binaries. You can also push updates remotely on any station, any machine, and whatever number of products you have, it's still one-click operation to distribute 1 or 1,000 products on 1 or 1,000 machines. The licensing part, we provide a very advanced licensing chain. You can control individual access, workstation access, specific code features, and you centrally manage all that in the cloud and all your customer base. And also, BLT provides tracking. You can monitor when your application is used, on which machine, which version. You get advanced error reports. You get notified by email when there is an issue in your application. So that's what BLT does. So I strongly encourage you to download it and try it. There is a free version available on the Tools Network or bltforlabview.com, and you're going to have a big dashboard where you have the control at any time of all your software deployments. So let's look at TOM. TOM stands for Test Operation Management. Okay, thank you, Windows. Yeah, I did. All right. So in this presentation, we're going to use TOM to test power amplifiers on different stations. So we have a development machine that we're going to use to build our test sequence, build our LabVIEW operator interface, deploy that on a server, and then we're going to install our application on different test stations. So on the development machine, we're going to launch our dashboard called TOM for Test Operation Management again. And we have a section called Manage Deployment, where we're going to be able to define our product and what's in our product. So we created an NI-Week demo product, where we're going to create 2 components. One component for the LabVIEW operator interface and one for the test sequence. And we want separate components because we want to be able to update either our LabVIEW operator interface or just our sequence without changing the operator interface, or we might want to add a new product line and just create a new component that will test that new product. So let's define our components in TOM. So we create a new component, demo sequence, you can add description, and we create our operator interface, which is again a LabVIEW application. Then we will configure the build specifications. You know what are build specifications. We're going to say what's in our component. So for the demo sequence, we basically link our component to a test stand sequence. So we create a new build step, which is a test stand build. We specify the test stand sequence, and Tom is going to analyze our test stand sequence file and find out all the dependencies that need to be packaged so you can execute your test stand sequence just with the runtime engine. Okay, so it found out all those dependencies. They're going to be packaged and pushed on a repository, so any station can get them. We do the same for our operator interface. This time this is a LabVIEW build, so we specify a LabVIEW project path. It will find the available executable build specifications, and again we are previewing our exe to exactly know what will be packaged with our component. And in this case we also want to add a shortcut for the operator interface on the desktop, so we can use Tom to create that. So our components are now defined, and we are ready to build them and release them on our online repository. So that's what we do. We specify the version number, you put some release notes to keep track of all what you do, and we push. So now Tom is again parsing our sequence file, analyzing the dependencies, and it will package everything in a single component. Done. All right. So the dev machine is now building and pushing this on a server, which can be anywhere on the world or just locally on your plant. And we can keep track of the releases, the date, the description. Let's do the same for the operator interface. So we build and release a new release, which is actually the initial release, version 1. And here, Tom is now calling the LabVIEW application builder API, and we're going to build our LabVIEW source into an executable. So we just need the runtime engine to run this. So also you save money on the license costs. Okay, you just use the runtime engines on the test stations. Let's build the installer now. Okay, we need to install our application on the machine. We build the installer only once because this is an online installer. It's 15 megs. There is nothing in it. It will just contact the repository and always fetch the latest version of the component. Again, if you add a new component, it's going to find out this new component without having to rebuild the installer. So the installer has been built, it's on the desktop, it's right there, it's 15 megs, and we're going to install it now on our test station 1. Any questions so far? Move on. All right. Let's go on test station 1, a fresh machine, just the runtime are installed in there. We could also include the runtime in the installer, of course. So we run our 15 meg installer, and it's going to contact the repository and list our 2 components, and you can see with the description of the component on the right. So let's install, downloading, installing, and our shortcut appears on the desktop as we defined it in the build specifications. Now we can run our operator interface in test station number 1. So this operator interface, the purpose of it is basically to programmatically launch our test stand sequence and give valuable information, only what the test operator needs. We authenticate our test station on the Tom server. We register the test station 1 as a new machine on the Tom server. And that way we're going to be able to track that test station live and its performances. So let's go back on the development machine where we have our dashboard. You can see that the test station number 1 appeared, it's been created, and the status is online. Also, it reports the products. We have one product, an IBIC demo, and all the components with the version installed and the latest version available. Let's do a change in our operator interface, and we're going to change the front panel color. A useful change, but just to show you how we can update easily our operator interface. So we do the change, we save our project, and then we go back in time. In the Manage Deployment section, we're going to build and release a new version for our operator interface component. You put some notes, increase the version number, and Tom again is building the executable and pushing it on the server. All right, it's done. Almost immediately after that, you're going to see, so we track all the releases, of course, it's very important. And immediately you see that already the test station 1 reported that a new version is available for the operator interface component. So the test manager knows the state of the updates at any time. So let's see how it looks on the test station 1. Test station 1 will see that there is a new version available. It's checking regularly for updates. So let's log in into test stand, and a new button appeared at the top of the operator interface, so to notify you that updates are available. When we click on the button, we have the details on the update, the release notes, the version number of the update, and we simply click download and install. It will exit the operator interface, download the new component version. So while we are doing that, our test station is not available for testing, okay? We are doing some maintenance operation. And the test manager can track that at any time. As you can see, the status is now maintenance, and the reason is software update. So the availability of our machine, is not ready now to test. If we go back and complete the update process, we don't want to reboot, we just restart the operator interface, and you can see that the new color appeared, hopefully, and it reports the new version number. So we did that on one test station. Of course, we can deploy on many test stations, and they can be wherever in the world. Again, in the dashboard, we can make sure that the new version has been installed, and we see that live in the dashboard. So let's do the same on test station 2. Okay, we have another fresh machine, and that can be located in another country, another continent, another plant. We run our 15 meg installer, find the components, install them. Again, the shortcut appears on the desktop. We launch the operator interface. As you can see, even if this is a fresh install, it already installed the latest version with the new front panel color. Okay, it fetches the latest version all the time. So we register this station as a new station. It's going to be test station number 2. And again, if we go back on the development machine or the test manager's machine, the test station 2 appears as online with, again, the description of the components installed. So I'm going to let Chris talking about some metrics that we care when characterizing the performances.
So let me start with a question. Do you feel that you understand your test station performance? Raise your hand if you think you understand how your test stations are performing today. And do you feel that you have that information coming to you automatically? You have something to back up that feeling? Cool. So, for those of you who didn't raise your hand, I'm going to be talking about 2 particular metrics that can help us understand how our test station is performing. The first metric I'm going to be talking about is OEE, and that stands for Overall Equipment Effectiveness. The second one, next to the pile of money, is the cost of failure. So, OEE is a composite measurement. It consists of 3 subcomponents that allow us to characterize that test station. The first one is availability. So, the definition of availability is the time that the test station was actually available. Genius, right? Well, It's the time that the test station was available out of the planned availability. So if we plan within all our production schedules for the test station to be available 24 hours, but for 2 hours of the day, IT are doing some maintenance, some upgrades, then we don't have 100% availability. So we need to understand, when was the test system actually available? And that needs to factor in things like software updates, preventative maintenance on test fixtures, and IT operations.
We already have an issue with YouTube videos embedded in the PowerPoint, so let's run this that way. Alright. So let's see how it looks in time. We are looking at a period of time that began 5 minutes ago and ends in 5 minutes from now. And as you can see, the availability of our station is around 50%, which makes sense. And as we continue looking, the availability is increasing because our test station is currently online. So you can look at that live. Let's go to our test station 1 and stop the application now. We stop the application and we are prompted to enter a reason. Why are you putting the test station offline now? So let's say we are doing some calibration maintenance. Again, on Tom, you can see live that the station is now in maintenance for calibration. And due to calibration, the availability stops increasing. Let's talk about another metric now.
So the next metric is performance efficiency. So when the site was actually available, were we using it to perform valid test operations? Having 15 sites available to your test organisation and having 3 of them sat idle is inefficient. Test assets and people are expensive resources.
So we can monitor that in test operation management as well. So in this case, we're going to run several tests on our test station number 2. Okay, so we click on run test, and the LabVIEW operator interface is now programmatically launching our test and sequence. We enter the UUT serial number. We have now a controller, a thermal controller, which is hitting our chamber, so then we can perform the test of our power amplifier unit. Okay, test passed. Let's do another test. Let's do actually 3 or 4 tests taken in. Oh, as you can see also you get the report and the results directly in the operator interface. That's the goal of an operator interface, to give valuable information. So if we look now on Tom machine, you can see that we've performed 4 tests. And the performance, so the time we were actually testing, is about 65%. So there is some downtime between each test that we've done. We're going to run 5th test. Moving forward a little bit. All right, oh, this test failed. Let's go back on Tom, on the development machine. And we wait quite a lot before the 4th test and the 5th test. So if we now change the period of time to actually look at the 5 tests, you can see that the performance decreased to about 40% because of that wait time between the 4th and 5th tests. So that's the performance. Chris is going to explain us another metric. We crashed PowerPoint in the meantime. All right.
So the final piece of OEE is yield, our unit first pass yield. So here we care about the percentage of units that make it through the entire manufacturing test operation on the first try, without any failures and without any rework. So we simply got the number of passed units divided by the number of opportunities that we had to have a passed unit, and that gives us our first pass yield as a percentage.
So again, this is something we can track live. I don't have closer now. Right. This is something we can track live in time. So we performed 5 tests, you remember, and there was 4 passes and 1 fail. So if we look at the quality, the yield of our test station, it gives 80%. Yeah, the calculation is right. Now, if we multiply those 3 metrics, we get the overall equipment effectiveness, a single metric to characterize our test station. And we can look at that for any period of time, any station, any product that you have installed on those stations.
So, to recap, we've got our availability. So from the planned time that we were going to use the test station, how long were we actually available to use the test station? And when we were using it, or when the test station was online, what percentage of time was it actually performing test operations? What time was it actually adding value to our organization? And then when it was performing those tests, what was the quality? How many past units did we actually get through that? So by taking those 3 measures, availability, performance and quality, and multiplying them together, we get OEE, a single figure that allows us to, at a glance, understand the performance of our test operation. The next metric is a little bit more straightforward, the cost of failure. Not very often do I see organizations actually calculate and spread that information out to the people performing the test operations themselves in the manufacturing test area. The cost of failure is simply the cost of non-productive operations being performed multiplied by the hourly rate. So by non-productive, I mean of the total test duration minus productive duration, that's the non-productive time. So if we were performing a planned, past, completed test operation, that's great, it's productive. But if we had to retest because somebody moved a cable, or we realised that one of the pieces of equipment was out of calibration, that's non-productive time, and it has a cost associated with it. So we take the time spent doing those things, those retests, those failed tests, we multiply it by the hourly rate, and that gives us the cost of failure. And that's a really powerful metric to see up there in lights. People can relate to seeing a figure. They know we spent $50,000 or $100,000 on failed tests because a cable wasn't connected correctly. Well, they can relate to that. It's like a third of the value of their house, or it's their annual salary. It's a very powerful metric, and it gives them a sense of that operation that they performed that they didn't do correctly. It gives it a sense of value.
All right, let's look at some code. You like code, I guess. So Tom comes with an API for LabVIEW, of course, and that's what we use to report information. So Tom API for LabVIEW, we start by, if we look in the palette, there is 2 VIs at the top, the init Tom instance and the check server connectivity. So the Tom instance basically authenticates, do the authentication on the server, the machine registration, and it gives you a class, an object where you have several informations about your machine, and you can check the connectivity with the server at any time. There is a subpalette update. Okay, there is 2 VIs in this subpalette. Check components and actually perform the update. So the check components gives you the information about installed components, all the components existing for that product, the ones that are new and the ones that are updated. And for each component, I get all the detailed information, the release date, the update text, whether it's installed or not, etc. And then we use the perform update VI to install the new components and or update the new components. The events, which is probably the most important palette, okay, the events palette. We're going to look now at the set online VI. So when we start our operator interface, we use the set online VI that gives us an event ID. And then we will use that same VI with this event ID again and again. We kind of ping the server to tell, hey, I'm still available, and there is a watchdog system. If you stop pinging for 1 minute, we can assume that something crashed. When you're done, when you exit, you call again the set online and you set it done. So we specify that we are not online anymore. Another event that we provide is the set maintenance. As you saw when we closed the application, we were prompted for a reason, so you just use the set maintenance event, you provide the reason, and while you are doing your maintenance, it's in maintenance, and then you just say, hey, I'm done with the maintenance. So this is how we track all this. And now the test event. So there is 3 VIs to characterize our test: the test begin, test data, and test end. When you start your test, you use the test begin, and you can pass any data. In this case, we use a minion, but you can basically wire any data to that, and this is optional. You perform the test, and again, you can send some intermediate results of your test, but this is optional. Maybe what you care is just pass-fail in the end. And that's why you use the test and VI, and that's where you actually send your results, pass-fail. You would eventually also provide if the test has been terminated or in error, so this is things to add. We also provide an advanced palette. The advanced palette allows you to open a connection to the server and basically access, the same as in a database, access all the records. So we have the products, the components, the releases, the machines, all the events log. You can upload file on the server, and it works the same as a database. You have add, delete, select, and update method for all those records, and this is using objects, LabVIEW classes.
So, to give a little case study and understand how you can be impacted by using these metrics, I'm going to go back to our RF OEM. So, just to recap, it's an opportunistic market, spot orders. Often a customer will simply contact and say, we want 10,000 units and we need them in 3 months. If you can do it, great, the order's yours. If you can't, we don't care about the other stuff you can do. Can you fulfill this particular order? Because of this, it's often a temporary workforce. The volume that they're having to produce flexes rapidly over time, so they often use contract staff to achieve this. And there's the high cost of test. The test equipment is expensive. You can't afford to have racks of equipment sitting around just in case you win an order. So, a spot order comes in, and typically what they would do is go and hire some agency staff and rent an additional test station, one of these expensive test stations. So we implemented OEE. We started looking at the test performance so we could better understand what is the capability of the test solutions, the test environment that we already have. Is it optimized? So to use the old adage, measure twice, cut once, we can't improve what we don't understand. So they implemented OEE. And because of that, through measurement and capturing of all test station activity, they were able to reduce the UUT cycle time. So what came out of OEE was that actually, in between performing tests, the test station was actually sat idle for several minutes because the test site operator was actually performing some other operation. He was loading a unit onto the next test fixture. So it was sat idle for several minutes, not performing value-added activity. So the first thing they did is they put alarms, very rudimentary, but they put alarms and sirens on top of the test station to draw attention to the fact that it needed servicing. It needed somebody to come and load another unit on there. They also recognized that by having a single calibration period during 1 week of the year, that meant that all test availability was down during that week. They had 0 test availability, but also they were still suffering from periodic failures of test jigs, pogo pins bending, etc. during the year that was causing additional downtime. So they implemented a preventative maintenance schedule so that they could reduce that downtime and have maximum availability out of the planned availability. So we've reduced cycle time. That has led directly to an increase in the volume capacity of that production environment without having to buy new test systems, without having to hire additional test resources, and they've increased the availability of those test stations by performing preventative maintenance. So overall, a great success because they've increased the volume, they've increased their ability to respond to those spot orders without having to spend money on expensive test systems and hiring staff. So, OEE was used successfully. If you'd like to come and talk either to myself or Matthias more about OEE and how you can use metrics, please come and see us afterwards. If it's something that is of interest to you, we can be our contact details are there. We also have a blog, walkingthewires.com, where we talk about technical concepts, also some hardware posts on there about how we do hardware design, and Matthias also, BLT.
ForLabView.com, we have some business cards at the front if you want to take some as well.
Okay, so any questions from anyone?
Does Tom integrate with Testan?
Yes, so as you saw, we were able to directly parse our sequence file, build a component, and push it.
Okay, but the APIs you showed a lab
Yeah,
demo.
we use it in a test and sequence actually.
Okay.
So basically the LabVIEW operator interface is programmatically launching the test and sequence, and it's the test and sequence itself that is calling the LabVIEW API to say, hey, I pinged in my test, this is the result of my test. Chris implemented that in a process model. We have also an example with it's just the step test begin, step test end.
So you've got a couple of, we've got three options to you if you actually want to implement Tom through Testan. You could implement the API through the operator interface and then use callbacks to get the information that you need back to the operator interface. You could implement it in the process model. So on the sequence file execution start, you could call the Tom test begin API method and then use the post-step callback to capture the test data and the overall result at the end of the sequence of execution. Or you could implement it in the client sequence as well. You've got three options for how you could implement that.
How is the data saved on the server side?
There is a database in the end. We are using web services to communicate the data, so we are basically calling web services, sending the data to the web service. The web service itself saves it in a database.
Okay, that's configurable, like meaning like if I want to use a different database, it's that.
Oh yeah, definitely. I mean, you can install on whatever server you want, and it can handle different SQL databases technologies. You can also, it's not right now, but you will be able to define your own events. So what do you mean by configurable?
Yeah, for example, what database is using the...
So right now it's MySQL.
Okay.
It's powerful and free. There is no reason why you cannot use with Microsoft SQL Server or Postgre or Oracle.
That's all.
Yes?
How did you guys do the installer? Did you build your own, or did that look like a Windows installer that did the update or the initial installation of the software?
So there is plenty of installer technologies. I know setup. This one is using the Qt installer framework.
Okay.
Yeah, there's other. This one is using Qt.
Thanks.
Couple other questions. How long have you been developing the Tom software? How many companies have been kind of using it? And from your own opinions, what are some limitations you found?
So I'd say that this is a product in development. Okay, we made a proof of concept here. It's a little bit more than a proof of concept because it really works actually. So we are still looking for maybe help partners, customers that would like to give them the best feedback, the best need they have to finish up that product. So no one is using that one yet.
To add, have you guys heard of Weinman Technologies? They pretty much do the same exact thing, just with Verisign. Maybe you do.
I didn't look at that.
Do you know?
I mean, I know the company. I didn't know that they have that. So yeah, we'll look at this definitely.
Maybe help each other out.
Sure. Thanks for the lead.
I think that's it. Okay, thank you very much. Thank you.
Don't forget to.
Oh yes, yeah, don't forget to do your survey.
I don't think it works.
Yeah.
It doesn't work apparently.
Thank you.